Hi guys, we're just going to go through equations today. So if some of you are already comfortable with this, obviously when I'm writing down an equation, just pause, work through it, and then unpause, and then get to the end of that question, see if your working out matches up with mine. If you are just writing down answers and you submit them as answers, I will be returning them to you. So I would say right now, please make sure you show your working out. So when I'm asking for your equations, you need to make sure there's working out. Okay, so let's just get started. So this is the first sheet. I'll also run through a couple of examples on the second sheet as well, because I know there's quite a few of you that all of this is something that you've definitely done before and you don't need to focus on, and you need to focus on more challenging things. Okay, so let's just run through a few of those examples. I will be showing for this sheet, I will be showing a visual as well as the abstract. For the next sheet, I'll probably just stick to abstract. Okay, so running through this one. 4x plus 10 equals 30. Okay, the reason why I'm going to run it through the working as well is just for those people that need that little nudge to show them how to do it. So if you did pause, that's fine, you're just going to the end. If you didn't, we're going through working as well. So it's 4x plus 10, that means I've got 4x's plus 10 equals 30. So that means this must be 20. For 20 divided into 4 pieces, because I need to share is divide, x would equal 5. If I'm doing it from an abstract point of view, doing exactly the same thing, taking away 10, left with 4x equals 20, share into 4, and then x equals 5. Yeah? Next one, x over 2 plus 11 equals 19. X over 2, 11. Altogether it's 19, so that must mean x over 2 is 8. X over 2, for those people that don't know, is the same as saying half x. So if I've got half of something, how do I get back to a whole? I just need 2 of them. So if x over 2 is 8 and x over 2 is 8, then it means altogether it's 16, which means x is 16. And then I'm just running through exactly the same thing in the abstract method as well. You just need to make sure you're writing down what you're doing in each stage. So I take away the 11 first, I'm left with 8. I then need to multiply by 2, because that's what I've done. X equals 16. Okay, next one is x plus 5 over 3 equals 12. That means this whole entire expression has been divided by 3. So I'm saying x plus 5 into 3 pieces is 12. So altogether it's 36. And then this one by itself must be 31, because I had to do 36, take away this 5, which gives me 31. So x equals 31. For this one, you would still multiply by 3. Anything that is a numerator, just imagine there is a set of brackets around it. You can't disturb it. You can't just take out 5 or anything else that you want to do. So I'm going to times by 3 on both sides is x plus 5 equals 36. Then take away 5 from both sides. X equals 31. Okay? Now we look at one of the brackets, and then I'm also going to look at one in section D as well. Yeah, let's do that. So I've got 3x plus 2 equals 15. That means I have 3 lots of this. So 3 lots of x plus 2. So I'm going to put x, 2x plus 2, x plus 2. Altogether, this is 15. Okay, that looks very messy, so I'm going to rearrange it. I'm going to gather these x's together, so I've got 3x there, and then I'm going to gather those 3 2's together as well. So that is still 15, I haven't changed that. But now I can easily say that 3x equals 9, because 15 take away 6 is 9. I need to share that 9 into those 3 x's, so x equals 3. Okay, on this side, I would expand the bracket, which would give me 3x plus 6 equals 15, which is exactly what I've done here. 3x plus 6 equals 15. take away 6 from both sides, you're left with 3x equals 9. Divide both sides by 3, x equals 3. Some of you may have noticed that this number is a multiple of this number. So I would only ever use this second method if this number is a multiple of this number. Otherwise, I wouldn't, because otherwise you'll be carrying fractions all the way down and you don't want to do that. So if this number is not a multiple of this number, I would always personally use this method. But if it is, then I might just shorten that method and just divide it by that. So if I divide this by 3 and I divide this by 3, I'm left with x plus 2 equals 5. I then take away 2 from both sides, it's x equals 3. Okay, if I wanted to do that algebraically, I could have actually done it from up here for those people that were noticing that. I'm saying x2, 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 right? And I'm saying altogether it's 15, so each part must be 5. And then when I found out each part must be 5, that means I know that this equals 3. Okay, so you can still do it via the bar model. Anywho, last but not least, let's choose one of these ones from section D. Let's choose 10x plus 10 plus x, equals 6x. Okay, so that means I've got 10 plus x at the top, and then I've got 6 lots of x at the bottom. I've got an x at the top, x at the bottom. I can just get rid of them. I'm left with 5x. So each of them must be 2. If I do it from here, I've got to take away an x from both sides. Left with 10 equals 5x. I then divide that by 5. I'm left with x equals 2. 2 equals x, same thing. Okay. Okay, so this final one where you've got something more challenging. Obviously you've got the fractions at the top, which is just a variation of what we've already done. So you can do that. Run through one of them, yeah, because it's got 3 terms. Okay, so I'm going to go through 5 just because it's got 3 terms, just so you're used to that one. So you've got 8x plus 1 take away 4 over 8 equals 7. Okay, looking at this, I could multiply by 8, but if I multiply this by 8, whenever you multiply, you must multiply every single term in the equation. So I can multiply everything by 8. So if I want to multiply this by 8, everything gets multiplied by 8. So I'm going to say 64x plus 1 take away 4x equals 56. So this just comes straight down because I've multiplied it by 8, so it's no longer an eighth, it's just a whole. So I can just say, oh, this over 1, I don't need to say that over 1 anymore. This then becomes 64x, and this becomes 56. So now I'm just going to collect everything. So I've got 60x plus 1 equals 56. I'm going to take away 1 from both sides. I'm left with 60x equals 55. Then divide by 60 on both sides. X equals 55 over 60, which just becomes 11 over 12. I'm going to leave that as a fraction because you can. Why wouldn't you? Okay, next one we have 4, 2x take away 3 is 8, open bracket, 2x plus 5. Okay, some of you might already notice the whole multiple thing. That's fine. If you want to work on that multiple thing, as long as you get to the right answer at the end, you should be a-okay. But I'm going to multiply out the brackets. So I've got 8x take away 12 equals 16x plus 40. Okay, take away the smaller x first. So I'm going to take away 8x from both sides. I'm then left with negative 12 equals 8x plus 40. Then I'll get rid of this 40 because I don't want it. So I'm left with negative 52 equals 8x. I then divide both sides by 8. I'm left with 8 equals negative 6.5. That is my answer. Okay, and last but not least, it's where you've got fractions on both sides. So let's just look at those. You should be able to do stuff like 1 and 2 because you're just multiplying it by numbers. I'll just go through, let's go through 10. 10's a nice one. Okay, so 10 is x plus 2, x plus 3 equals 4. Okay, so the important thing about this is remember brackets. Okay, brackets are the key to this. So if you have brackets and then you're moving entire terms, it's very easy to be able to move them. So I'm going to multiply both sides of this equation by this entire bracket down here. So then I'll be left with x plus 2, still a bracket, equals 4 times x plus 3, because I had to multiply both sides, by x plus 3. So this one got cancelled out because x plus 3 divided by x plus 3 is just 1. And this side actually got it multiplied. So then I have x plus 2 is 4x plus 12. I then take away the smaller x from both sides, which leaves me with 2 equals 3x plus 12. I am then going to take away 12 from both sides. I'm left with negative 10 equals 3x. I then divide by 3 on both sides, which is negative 10 over 3. Okay, so that is if you want to practice on these. I've run through the examples. Hopefully they should help you. I've done one in each style, so that should help you out. In regards to the next part, so you've now got the rest of the lesson time and your reflection time to see what you can do and get it submitted. Make sure you have working before you submit it. You need the working, you need to upload that photo, or you're working out if you've been doing it via iPad and you need to upload that sheet, that's fine. But you do need to upload the file with working out to submit. Okay, what I do next will just be for those people that were factorizing a quadratic expression. So if you just want to get on the work, that's fine. If you want to look at how to solve a quadratic equation via factorizing, then you stay on this wonderful video. Okay, so first of all, just to cover the really basic stuff. So if I have that over there, if I said to you, a times b equals 0, what would you say a solution would be? The solution would be if a equaled 0 or if b equaled 0. Yeah, because 0 times anything is 0. So one or both of them have to be 0. So we usually just say a equals 0 or b equals 0, right? We use the same for solving quadratic equations with the factorizing. That's all you do, you use that same methodology. So if I said x plus 2 and I said x plus 3 equals 0, then I would say, well, this part needs to equal 0 because that's my a, or this part needs to equal 0 because that's my b. Okay, so just using this analogy, this is my a, this is my b. This wouldn't be me solving it though, because I've got the variable and the actual number on this side. So I would say x equals minus 2 or x equals minus 3. Does that make sense? So this would be your answer. That wouldn't be your answer. That would be working out. That would acknowledge that you understand this would have to equal 0. Hopefully that makes sense. I'm not running through the factorizing today, but you guys are pretty good at it. So let's just look at one of these. So this one hasn't been factorized, so then you would have to factorize it. So once you do factorize it, you should get this. Okay, so the answer would be, otherwise if x plus 5 equals 0, so x would have to be negative 5, or x plus 3 would have to equal 0, so x would equal negative 3. Does that make sense? So that's all you need to do for that one. And then at the bottom, they're just trying to confuse you a bit, which is all good. But at the bottom, it's just introducing you to squares as well. So if I had, say, x squared take away 20 equals 5, what would I do? self-defining equations by factorizing. Yeah, no, that's fine. So I would say take away 20, you need to add 20 to both sides. You've then got x squared equals 25. Okay, then you need to take the square root. Okay, the thing about quadratic, so quad comes from square, these are squares, square root. The thing you need to remember about square roots is that they always have two answers. You have the positive and you have the negative. So when I say x squared equals 25, x would have to be the positive or the negative of the square root of 25, which is positive or negative 5. Okay, so that's your two answers. Some people, I personally write it like this because I don't like writing a lot and it's a nice abbreviation. But some people would just actually put 5 or negative 5. It's entirely up to you. I would accept that because that's completely valid. Okay, so when you're doing this, just remember if you are looking in the online textbook, because I know some of you like looking in the online textbook, this is part of Unit 5 and it's part of the algebraic part. Okay, so I'm going to attach this worksheet as well. So if you want to run through those just to make sure you double check it, I would like to see a few examples of the actual fractional work as well. So for this worksheet, I would expect a couple of those, maybe up to 3 or 4, and a few of these just to make sure that you understand how to do section C. Okay, so you can do a few of those fractional ones, and then if you want to go through some of these just to make sure, it will practice your factorizing quadratic expressions and it will give you the solutions. Okay, cool, excellent.